Hello everyone, in today's video we're going to be getting started with Archean programming with the absolute basics. So first things first, we have our Xenon code. Like I said, if you saw the previous video, you kind of saw why I'm going through all the trouble of doing this. This is a common request. And today what we're going to be doing is just getting you started. So to get started here, of course, I'm going to go ahead and grab myself this lovely computer here. I'm going to go toss that. I'm in creative mode. Hold down the shift key, and I'm going to plop it down here like this. Now this computer, right out of the box, doesn't do much. It's got a bunch of inputs. I almost never actually use this computer. I find it's like a little busy for me. But again, I've done all sorts of fun things like operating systems and stuff like that. So what I'm going to do is I'm going to attach some power. We need some low voltage power here. You can see the little connector in the side there. I'm going to go ahead and click on that. Run over here. We'll go ahead and plug it into this. I never ever plug things into your primary battery if you can help it. And now we've got some juice. You can see it's going to detect some things. It's going to give us a little kind of heads up. This is a great system. We have plenty of memory. Oh my goodness, 60 megabytes. That's luxurious. We could do Final Fantasy 1, no problem with that. And of course, we have 12 I/O ports. You'll notice this big angry thing that says no programs found. So what I'm going to do first is hit the code button, and that brings up our lovely IDE. And there's a couple different IDEs. One thing I will do to make your life a little bit simpler is I'll make this a little bit darker, so it's you can't really see the background so much. It's easier to see if my background isn't clear. And we're going to go ahead and experiment just a little bit. So to get this thing started, a couple things you need to notice. Coming up here, we've got File, you've got Computer, you've got Options, and you've got Help. Now, when I come up here, you'll notice there's a program and a file. Big difference. Programs are programs. When you're working with mini computers, you can only have one main program. Files, you can have as many as you want. So I'm going to go ahead and hit New Program, and it's going to say Enter a new program name. I'm going to call this one Hello World. Press Create. And what you'll see here is when you first create a new program, this is always going to bring you into the Xenon Code IDE, and it's going to bring you into the node-based business. Now, if you've learned anything from me from last time, the node-based business is great until you start getting complicated. And again, you can do theoretically anything with nodes, but for me, it's just so much easier to do it in regular code. So I'm going to press Switch to Code, and I'm going to press Convert to Code. Now, you're going to get a bunch of stuff here at the top, which will allow you to go back to nodes, but let's be honest, we want the code. Fantastic. So the first thing you need to be aware of is the fact that this program is not running right now. If I look back over here at our AIO BIOS, you'll notice Hello World is basically hanging out there, ready to go. I can press Enter. It fires it up. Nothing happens because we haven't actually made it do anything yet. So naturally, you're not going to get much of anything here. But what we want to do is we want to basically make a simple program. Now, first thing you need to learn about Xenon is kind of its personality. Now, I've done programming for a very long time. My first programming language was BASIC, as in Tandy TRS 80 BASIC. Of course, I learned from C and C Sharp and C++, and of course, Xenon code reminds me a bit of Kotlin. It's just kind of got that vibe to it, but again, it's got some other flexibilities. And one of the important things you need to think about is what they call entry points into our program. Ignore the fact I keep having to hit the little Windows key button there and bring all that junk up. And the reason for that, of course, is you have to press the Alt key to get your mouse back. Sorry about that. So one of the important things you have to do is understand is program entry points. In Xenon, there are different ways to get into a program. Now, back in my old days, we did one of these things. That would be your basic, basically, kind of a thing like that. But this program doesn't need that. Instead, it simply needs something to tell it where it goes. Now, if you're coming from basic, again, using another example there, if I were to do a print hello like that, if I were to run my code, you get a very angry warning. And it would say that your first word is in the global scope. Now, there are two main scopes in Xenon code, and a scope is simply consider this as an area. For example, a scope could be in your house or it could be on your property. The global scope would include everything in your property. Your standard stuff where work gets done would have to be in your local scope, which would be within your house. Now, the simplest thing we can do to solve this problem, of course, is to use a command called init. Init, and then if you want to go back to the old days of assembly programming, is basically going to be a place that always gets triggered when your code gets run first. Now, if I just type in init chilling up at the top, by the way, this is bad programming. You want to give yourself a little bit of space here. If I were just to run this code, I'll say first, you'll see nothing happens. We trigger this init. There's nothing in it. See what I did there? And of course, if we want to actually do something in it, we have to put something in it. So I'm going to press enter and press tab. In Xenon code, a tab is how you delineate things. So for those of you who are not familiar with that word, think of it as a fancy way to say putting it in a specific spot. When I tab something, it becomes part of the thing above it. In this case, the thing I'm creating is called init. The thing I've just tabbed in belongs to init. Again, think of this as living room, for example. And now anything that's tabbed under it becomes part of the living room. Now let's go ahead and say we want to go back to what we were doing. Let's go ahead and do our print here. So I'll type in print, left parenthesis, quote, hello. Now remember, just like anything you open, you always close it. So if I open myself a parenthesis, I close myself a parenthesis. If I open a quote, I close a quote. And you can see here we have a string. A string is a fancy word for a word, and it's also containing quotes. Now if I run my code, this init, which always gets started first, will trigger this once. So to run my code, you're sitting there going, oh, where's the button? Where's the button? All you have to do is save. Now, if I save my current file, you'll notice down here at the bottom, you will see the word hello, and it'll appear once. See how that works? Kind of cool. So let's say we want to use another one. Now, init is awesome. I usually use init for the purposes of initializing variables, getting things set up, making sure it's all working square and well for us and stuff along those lines. And that's really what init is for. But there are other things we can do. Now, I'm going to go ahead and get myself out of init right now. I want to leave the living room and go and make myself a kitchen. The other thing we have that you're going to use quite a bit is going to be something called a timer. Now, a timer gives you the ability to define how often something happens. Now, if I type in timer, we just have to define how often we want it to happen. I can type in interval, which simply says how often between things, and I can do something like 1. So what you're saying with this program endpoint, you're saying create a timer, set it to happen once every second. Now, if I wanted this to happen twice a second, my interval would become 0.5. If I want it to happen 4 times a second, my interval will become 0.25. Now, you're sitting here going, can I do this? No, you can't do that. Unfortunately, our interval, that's too small of an interval. Remember, we're 1/25th a second here, so you have to keep everything within a 25th. I just got to be mindful of that. But let's say I want to do something twice a second. Now, remember a minute ago, I was talking about that scope concept? This print is owned by this init. Now, we want to be able to put things into the time interval. Think about this as kind of like, we're going to go down to the basement now, and I'm going to put some things into the basement. So I'm going to do the same thing. I'm going to come down here, press tab, and we'll go ahead and do a print again. We'll keep it nice and simple. We'll do hi this time. Now, watch what happens when we run our code this time. Again, there's no magical run button. I'm just going to go ahead and do a save, Control S. Watch this. You will notice your program said hello, and then it immediately started saying hi, 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 forever. How do we stop it? Well, there's a lovely thing that says the word reboot, and we just got to find the button for it. Let's get my thing back. Here we go. Boop, reboot. That'll stop it real quick there. Boop, 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 boop. And it says start program. Boop, enter. Hello, hi. But again, notice our program immediately said hello, and notice when it started running is when it started saying hi. Now you're starting to go, oh, that's cool. Can I do different timers at different times? Yeah, you can. We could even do something really silly like this. It's interval 0.25. We'll print supdog. Now, if I run this code, see how the two timers are stepping on each other? Isn't that awesome? And again, these timers are fabulous, fabulous, fabulous ways to control how often something happens. My favorite example here is a blinker. We'll do a blinker later on. Don't worry, we'll get to that. But this is a great example of understanding how that works. Now, there are other imports points brought in as well. Let's go ahead and backspace that out. Press Control S. Notice, by the way, the program loads, inits, then it runs. Very important. There's another really, really important in point 2 called update or tick. Each one of those is basically the same. What this does is it executes the code attached to it every single tick. Now, if you remember, if we reboot this sucker, you probably caught the fact that our boot speed is 25 ticks per second. Now, 25 ticks per second is actually pretty quick, but believe it or not, we can actually cheat a little and get that ticks per second not higher, but we can actually adjust that within the code because there's something kind of sneaky going on here. And I don't really want to give you that hint yet because I don't want to send you down the wrong road. And trust me, we can go a lot quicker than this without cheating too hard. But again, I'm going to leave that alone for now. But if we want something to update every single tick, remember we got 25 of those per second, we can either type in tick or we can type in update. I like update better. For me, that's a little more intuitive. Keep in mind the difference between tick and update, server client. That's the way I do it. So now if we were to come here and type in update and do hi, this is going to be a disaster for us because we're going to be printing the word hi 25 times a second. Bam! And you can see how fast that happens. Oh boy. Stop, 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 stop. And you can see just how aggressive that is. So at this point, you should have a pretty good understanding of how these two inputs come. Almost every program you're ever going to design is going to have init, and almost every program you're ever going to design is probably going to have update. But there are other choices too. Let's say we wanted to design a program that maybe we push a button and that causes something to happen when we push the button. This in the old days, we called these keyboard interrupts. And an interrupt simply basically gives you the ability to trigger something at a specific point. Now, the first thing I want to do is I want to go ahead and disable this update here. There's a couple different ways we can do that. We could just come in here and delete this, or if we prefer, we can put a semicolon in front of it. When you pop a semicolon in front of something, you comment it out, which now means that that code will not execute. Now, if I run this again, you'll notice here that we've got a little hello down here at the bottom. It says hello world is running, and notice it's not printing the hi because we have commented it out with that little semicolon. Comments are actually really, really, really important to us. We'll be dealing with that a lot later. But anyway, let's do some wiring real quick here. I'm going to grab myself a button. I'm going to go ahead and take this in. I'm going to go ahead and plug it in there like that. And what I want to do is I want to push this button and I want something to print. So the way we're going to do that is we're simply going to design an interrupt. Again, I call them interrupts. They call them input functions in the documentation. So we're going to go ahead and type in its name and its number. So I'm going to do input.0. And you're saying, where'd you get 0 from? Right there. 0? Aha, ha, 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 ha. You get my feels. And what we're going to do is we're going to pass an argument. Now, this is getting a little advanced for us today, but the reason I want to do this is just to demonstrate how well this works. I can say if arg, and we'll print, what do you want to print today? This button pushed. Why not, right? So let's do logic here. When this button is pressed, it's going to trigger an interrupt. This interrupt is going to say whether or not it is turned on. We're going to say if it is turned on, because the value would be 1, we're going to print button push. Otherwise, we're not going to do anything. Let's give it a try. Control S. Ready? Boop. Ha-ha. Now, if I hold down the button, you can see we got a couple buttons there to appear on the screen. And again, you can see how darn effective that is because I can design these interrupts as a way to basically do these things. Now, the crazy thing is this interrupt here, we don't even need to use my port index. There's some really terrifyingly fun things you could do with this, but that is way outside of what we're doing today. At this point, you should be comfortable understanding the endpoints of your program. Again, that concept of scope. Again, we have our inits, which you're almost always going to have. This would be setting up values. We don't technically need it if we don't want it. We have our interrupts, which gives us the ability to basically suck in a value immediately and respond to that value. Like I said, it's awesome for things like switches and stuff like that. And then you've got your update as well as your timers. Again, things that go a certain number of times per second. If you can understand those basic inputs, you're always going to have a good idea of where your code needs to go. In the next video, what we're going to do is we're going to take a look at variables. It seems kind of weird to be starting right off with variables, but variables are very, very, very important. And we'll take a look at that next time. Enjoy.